Integral from 0 to 1, e to the minus 4x dx. We tell you how many sub-intervals to use, but when you are the researcher, you decide how many intervals to use. But for the homework purposes and exam purposes, we actually tell you that. So here is a notation. Solution. They give you n. Okay, too small. N is 4 sub-intervals. To visualize, you can say it this way. You have 4 intervals, 1 interval, 2 interval, 3, and 4. That means you have 5 points. Then, what is your A and B? Who knows? A and B are the beginning of the interval and end. Yes, 0 and 1, good job. So we have starting point 0, end point 1. This is what I see just from looking at the integral from 0 to 1, and then I was told to use 4 subintervals, but some people choose. So we need to find, so we know, let's see, we know. Now let's start actually finding. Find the step size, delta x. Delta x is the width of each rectangle or whatever we're going to be using, but basically it's a step size. This one has a formula. Take the whole interval and divide by the number of subintervals. So it will be 1 minus 0 over 4. The step size is 1/4. Step size is 1/4. Then there is notation which you don't have to remember, but the professional way to write it down, x sub k is the beginning, A, and then step size multiplied by k, where k is the counter. I guess it's fine. K is the counter from 0 to 1 to 2 to 3 and so on. To n actually, or n minus 1, depends on the situation. So this is how we're going to be jumping from one point to another point. But usually people visualize. They don't use this formula. They visualize the situation. Well, we can actually write it down. For our case, x sub k is, we start from 0, and then we do 1/4 k. So every next one will be adding 1/4. Let's see what it means. That means that from 0, we're jumping to 1/4. Then from 1/4 plus 1/4 gives you what? 1/2. 1/2 plus 1/4 is 3/4. If you don't know how to do it fast, imagine money, which are quarters. That's actually helpful. And we end up with 1. So now we know all the intervals. This is what delta x. Every time the width is the same, so it's a step size. Delta x is the same. And we have 4 intervals. 4 intervals. Check that. If you messed up number of intervals, it will not be good. And now we're going to do 3 methods. 3 methods. Method number 1. And that's what you should be able to do on a test. And of course, practice in your homework. The first method, let's do midpoint. This is the one we learn in Calculus 1, midpoint. Surprisingly, it is actually pretty popular, midpoint method. Midpoint is annoying because in this formula, let's keep some space, I will fill it up later, but the formula says, let me make it fat, m sub 4, because we have 4 intervals. Delta x is factored out, it's the width of each rectangle. And then f of x1 bar, because we cannot use the first point or second point, we're going to be using middle point. And this is the one we have to find. So that's the annoying extra step. With computers, it's done pretty fast. By hand, it's pretty tedious. So usually, this method is pretty good, but used by computers. So this is the formula. I only stopped, as you can see, at 4. I have 4 intervals. So I need to find midpoints. So where x, k, bar are midpoints. That's why the name called midpoint method. We don't know them, so we'll have to find them very quickly. From 0 to 1, 1, 2, 3, 4. Then what is happening between 0 and 1/4? 1/8. So that's what we're going to be using. This is f of 1/8. And some people write it down right away. That actually saves lots of time. So what is delta x again? 1/4. So m sub 4 is 1/4 f of 1/8, midpoint. What is the middle between, maybe I should write it down, 0 and 1/4, then was 1/2. What is the middle from between 1/4 and 1/2? 3/8. 3/8. Create common denominator, add up and divide by 2. So I will have f, bless you, of 3/8 plus 1/2, then it was 3/4. What is half between 1/2 and 3/4? 5/8, thank you. 5/8, f of 5/8. And finally, the last one is easy to find because it's 1 minus 1/4. So it's 7/8. Or you can keep adding 1/4, that's fine too. But you can also subtract from the end point. F of 7/8. Boom, you have that. The thing is now you actually have to find those numbers. Equals. And then I'm reminding myself, what is f? F of x is what? E to the power -4 what? X squared, thank you, good job. So basically what we're working with the integral from a to b, f of x dx. And this is what we're doing. F of x creates the graph of the function. Here it is, for example. I actually do have graph of that function at the very beginning of the slide. And then we're looking for this area, but since we cannot find exact area, we're approximating with rectangles using it in middle points. Here they are, midpoints. We find them, we plugged, midpoints we found on the x-axis as inputs, plug them to the graph of the function to have heights of each rectangle. And now we're gonna do that. And it's gonna be 1/4, let's go fast. 1/4 E minus 4 times 1/8. Put parentheses everywhere, that will save you from mistakes. Plus e to the minus 4 3/8 squared plus e to the minus 4 5/8 squared plus e to the minus 4 7/8 squared. And now you take a calculator, and that's the awkward part of this. You still need calculator after all, but most of the stuff is done by calculator / computer anyways. And you calculate. You don't have to take a calculator. That's just, I'm saying, in general, as a scientist, that's what you do. 0.4414. Put it in the box because we will be comparing this answer with others to see which gave you a better approximation. And I know the good answer. I know the answer done by good computer. So we're gonna see if our approximation is good enough or not. So that was not new. We did this in Calculus 1 in your previous life. Maybe you remember that or not. Now let's actually do new stuff, which is trapezoid method or trapezoidal method. People did not agree on that. Trapezoid. Трапеция. That's how you say it in Russian. Трапеция. Trapezoid method is T sub 4. Now remember different formulas. So on the test you will have to, you'll be required to recognize different formulas or write them down by hand. Delta x over 2 this time. And then standing by themselves edges, but multiplied by 2 or doubled the points in between. So since I have 4 intervals, let's see carefully. I have 4 intervals. How many points I will be using in this method? 5. See, I have 1, 2, 3, 4, 5 points. Last time we had 4 because they were midpoints. That's why the number of points matched with number of intervals. But usually, it's not the case. So since I have 5 points, I know it will be 2, 2, 2 in the middle. 2, 2, 2. And then this standing alone edges. The first one and the last one. Fx of 5. And there should be 5 of them. Or if I started from 0, 1, 2, 3, should be 4. If you start from 1, it will be 5. If you start from 0, it will be 4. You can ask which one is the correct method to do it. Both are correct. Traditional people start with 0 in computer science and math. But you will see starting from 1 as well. So I was trying to visually tell you how to memorize. So it has 2, 2, 2 in the middle, and 1, 1 at the edges, and also delta x divided by 2. The idea is when you look at the same graph, but now we're using trapezoids, then all sides in between are used twice, see? So side used for the right trapezoid and left trapezoid, except the last ones. The last ones are used only once, so kind of this is the way you can remember. Now, you plug points. You already found those points. 0, 1/4, 1/2, 3/4, and 1. That's why I left them here. This is the points usually people use, the end points of each sub-interval. 0, 1/4, 1/2, 3/4, and 1. Quickly write it down and get the answer. So delta x is still what? 1/4. So we're gonna do, let me do 1/4 over 2. F at, maybe you can go and write it down. It's gonna be 0, 1/2, 1/4, 1/2, 3/4, and 1. If you want to do it with a pencil, doesn't matter. Just go fast. Let's not rewrite it. That's too much of writing. So we're gonna have e to the 0 plus 2, e to the minus 1/4 squared, and I think multiplied by 2, right? Yeah, multiplied by -4. -4 plus 2 e minus 4 1/2 squared plus 2 e to the minus 4 3/4 squared plus 1 times e minus 4 times 1 squared. Let me put it squared. This gives us different approximation. 1/4 over 2 is 1/8, by the way, if you want to simplify. But the whole point is to find approximate answer. An approximate answer for this second method is 0.4403. Put this in the box. We already see difference. 0.4414 or 0.3. So which one is better? Again, does it matter if you work with space science? Probably not. Couple kilometers here and there, who cares? But again, I told you, if you're working with microscience, which is microbiology, engineering has lots of small details, then that's 0.001 step might be cutting extra cells of the liver, okay? You were supposed to cut off some cancer cells and you kind of missed it. Now you're cutting the liver. So that will be important. So in microbiology, and that's why cancer studies and microbiology studies are so expensive, because this is important. And that's why very supercomputers are used for these studies, and they are very precise. Simpson's rule. Simpson's rule. That's the new one, and it's very, very famous. Imagine that they're using Simpson's rule around the world right now while we're learning it. So that's pretty cool. First of all, we don't know if we can use it, because only should be used for even, not evil, even, only for n equals even, not equals, n even. But we chose n to be 4 and it is even. So if it was n to be 5, you as a researcher have to change that and figure it out. And of course, we never give you odd number of intervals for the exam. That will be weird. So that's what scientists do. They actually figure this out. S sub 4 has a weird formula. Not only it's delta x over 3, remember that, and then it has a pattern. Does anyone remember a funny pattern? Oh wow, people are good. I do not remember it right away. 1, 4, 2, 4, 2, 4, 2, 4, many times. But the important is 1 and 4 have to be the ends. So you see, I have way too many points here because I just randomly wrote down the pattern. We need 5 points. So I'm like, okay, 1 and 4 goes to the ends. Now it's only 1 point missing, so 2 in the middle. See? So that's what I'm going to have in my case. 1 times f of, and let's just put it right away, f of 1, right? Or if you want, I guess let's be consistent. Formulas, let's be consistent. Plus 4 times f of x2 plus 2, that's the only one with 2, f of x3, the middle one, plus 4 f of x sub 4 plus 1 f of x sub 0, 1. Okay, so I keep skipping 1. Should be x0, x1, x2, x3, x4. And as you can see, I always notice at the very end because I know how many points we have. So that's very typical to notice mistake at the end when it doesn't match the number of points. Put this in the box. That is the formula. You need to learn how to build by yourself. Wow, okay. Let's try again. Nice. So I will cross this off so you don't have bad notes. And now we know where to plug everything, so we start plugging it right away. Delta x is still 1/4, but this time divided by 3, so it's 1/12. And then e to the 0, which is 1, plus 4 e to the minus, I should write down, or okay, fine. 4 1/2 squared. These you can reuse from the previous example. That's the thing. You will be calculating this anyways. So you can actually reuse it right now. Do you know what I mean? So from previous example, I already calculated that this is e to the minus 4/16, which is some kind of number. So let me write it down for you once. The other one I already calculated from the previous example, it's 4 minus 4. The other one I already calculated was minus 4 times 9 over 16. And finally, e to the minus 4. So you can reuse from previous example. And that is approximately 0.4409. Again, it did not match the previous answers. So they all have different answers, and you need to decide which method is the best for this particular function, in this particular case, with this particular number of intervals. And before I tell you the answer for this question, I just wanted to mention that several things. Number one thing, do not approximate too early. That is a typical mistake of a newbie who starts working in applied STEM. So engineers and physicists, you will be using that a lot, biologists too. You will be approximating things. It's a student nature to approximate this as whatever, like 0.7. No, you don't do that. If it says 0.7, 1, 3, 4, 8, 10, then you better keep it like this. For each of those, you keep at least 5 decimal places. And then at the very end, you cut it. If you cut it way too early, then the answer will be cut off way too much. Because you might understand from logical point of view, mistakes accumulate. Arrows, they roll over. And that is why you should try to avoid to make mistakes on every single step of calculation. And computer actually knows how to do that. We do code computers so smartly that on every step, it should minimize the error. Because if every step has way too big error, the total error is too big, and it will be impossible to know why. because you can't go back and find which arrow messed up. So you will be seeing that your homework won't accept correct answer because you have a couple decimals off, because you rounded it too early. Round at the very end. So there's two ways, or no, more than two ways, to know which estimate is the best. Way number two is, let me do way number two, which is the most obvious one. Let's see. We have three answers, 0, 4, 4, 14, 0, 4, 4, 0, 3, and 0, 4, 4, 0, 9. Okay, so if you're a scientist, which one you're going to use? Well, you can take a better calculator, right? Or a computer program, and actually see what their approximation is. So if I type integrate e to the minus 4x squared from 0 to 1, this program uses better approximation. Mathematica was coded differently. It uses approximation using series approximation, which we will be using next month. Next month we'll be learning series approximations and stuff, so you will know what code they're using. But as you can see, it doesn't give you steps. There is a reason for that. If you check it in computer, it says it's approximated 0.4410. So which one is the best? So I used better computer and it gave me 0.4410. Which approximation was the best one? Simpson's. So we're gonna choose this one. Closest to 0.4410. Well, you can just copy. for 1041, but yes, I guess. Which we found with a better computer, with a better approximation, I would even say. So again, it's not the best, it's not the exact answer either, but it's done by a better computer with better approximation. One more thing to mention, there's no best method of all. Methods are better for different scenarios. If the function is very sharp, like a sound signal or a heartbeat, then parabolas might not work here because they are too curvy and smooth. So maybe actually trapezoid will be the best option. Or, as I mentioned before, triangles. If the function is smooth, then trapezoid one is way too sharp for that. So parabolas will work the best. And there are many more methods as well. But Simpson's rule doesn't work with odd number of points, and sometimes that is the challenge. So there are more methods than this, and they all have pros and cons. Some of them are too slow, and some of them are precise. So if they're too slow, usually they're more precise. If they're fast, usually they're not precise. In macro science, I was taught in NASA, they prefer to be fast and not precise. In microscience, microbiology, with bacteria, especially genetic sequencing and crisp cutting the gene code, they prefer to be slow but very, very precise, or else the whole experiment will be messed up. Finally, what I wanted to say was, all those methods do have errors. Errors were calculated. Errors were calculated. I'm not going to show you how to calculate them. It's time consuming, and I don't plan to test on this. You will see it in your homework, but the point is, I also do have examples in my videos how to do the errors. My point is, the errors means the mistake, the price of the mistake. As you can see, none of them give you the exact solution. All of them have gaps, including the Simpson's rule, right? They all have under or overestimations. That's the problem. So how bad the mistake is calculated using powers, cubic powers, fifth powers, and so on. The power means the better or worse mistake. So this one means the biggest mistake will be less than this number. The biggest mistake will be less than this number, so it's called error T sub n, error M sub n. So what is the worst scenario of your mistake? And you will be saying, oh, it's 0.007 millimeters. And then it's up to scientists or you to decide if it's bad or good. So these are the formulas. You will not need to memorize them. I'm not going to be testing you on this. But you will see it in your homework. It's part of the numerical integration theory, and some of you will be working with this in your job. It's a pretty popular idea. Finally, let's see if I have a box here. I don't think so. Okay. And sometimes we will ask you to work on this method with a box, which calls basically collection of the data points. And you will also see it in your homework and the video I explained there. So it's actually the easiest one, is using a table of data. Sometimes I will give you f of x right away, because it's too time consuming to find on a test, so that's also nice.